Okay, so what do you think about this sequence? What's happening from term to term in this sequence? What's going on there?
It looks like it's being multiplied multiple times.
Yeah. How do we figure out like what number?
Divide 98 by 14.
Good idea. Yeah, because 98 divided by 14, that'll tell us what was multiplied, huh? 7, right? So it's being multiplied by 7 every time, isn't it? You could try it out with your calculator, make sure, and it works. Yeah, so it's being multiplied by 7. So is this arithmetic or geometric?
Geometric.
Yeah, this one's geometric. Arithmetic's adding, subtracting. This one's multiplying. It's not adding, subtracting, it's multiplying, so it's geometric. All right, well, they want the formula. They want the formula. So you know how to come up with a formula, right? The pattern is in the path. So let's come on down here. Start with 14, which is nothing, and then 98 and 686, 4802, 33, 614. All right, and let's write the path. Pattern is in the path. How did we get there? Well, the first term, you just start with 14. Nothing about the first term. There's no path there. You just start with that. But the next term, how did we get to 98? We took 14 and we multiplied by 7. That's how we got to the 98, right? We took 14 and we multiplied by 7. How did we get to the 686? We took 14 and we multiplied by 7 2 times to get to the 686, right? How did we get to the 4802? We took the 14 and we multiplied by 7 3 times. And finally, the 33,614. We took 14 and multiplied by 7 4 times. All right, let's summarize these. This one is 14 times 7 to the what? 1, 2, 3, 4, fourth power. This is 14 times 7 to the third power. This is 14 times 7 to the second. This is 14 times 7 to the third. If you want, you could say this one fits also. It's 14 times 7 to the 0 power. 7 to the 0 power, you might remember from your earlier days, is 1. That is 14. Anything to the 0 power is 1. That works. There is the correct pattern. All right. So now to finish it up, though, we need to have, we got to write the term numbers, don't we? So, because that's what we're trying to connect is the term number to the formula. So this is the first term, second term, third term, fourth term, fifth term, and down here we want the nth term formula, right? Okay. Do we see the connection?
Yes. Isn't it 14 times 14 times 7 n going up minus no n minus 1 going up.
Power like that? Yeah, beautiful. Good work. Yeah, the fifth term leads to a 4. 14 times 7 to the fourth, right? The fourth term leads to a 3. 14 times 7 to the third. Yeah, you all seeing the connections there? The power is always 1 lower. Whoops. It's No, I should just write one lower. The power is always one lower, isn't it? See how that works? The power is always one lower than the term number, right? The fifth term, the power is 4. The fourth term, the power is 3. Third term, the power is 2. The power is always one lower. So the nth term, the power is n minus 1. 14 times 7 to the n minus 1, isn't it? So there we go. There it is. Let's write it up here. This is going to be 14.7 power n minus 1. I think the way you type that in is 14 and then the asterisk, you know, which is the shift 8 above the 8 on your keyboard. 7 to the power, and that up arrow thing is the shift 6 above the 6, parenthesis n minus 1. There it is, 14 times 7 to the n minus 1. So we were able to find the formula. So we could go out to the 20th term instantaneously by just plugging in a 20 for n. We have power once we have a formula. This is the beginnings of math and science. This is how they do everything they do. Physicists, what do they do? How was electricity discovered? There was a looking at a pattern and a writing down a rule that was making things happen. That's all of math and science is based on patterns and being able to describe the pattern, write a formula for the pattern, predict the pattern, use the pattern to then accomplish other things. This is great training for young minds, future STEM people, science, technology, engineering, mathematics. The young folks that will be sitting in your classrooms, train them to work with patterns. That's the heartbeat of math and science.